So I'd like to take this opportunity to introduce our second speaker, Dr. Serkan Atesh. He is currently working for Oregon State University as an assistant professor, and his research focuses on pasture management for sustainable animal production. He's also worked in New Zealand and is fairly accomplished in the realms of animal science and agronomy. We're happy to have you, and I'll give you your time. Thank you.
Thank you, Chad. And good afternoon, everyone. Thank you for coming to this webinar today. Basically, I plan to talk about the role of legumes in dryland pastoral farming systems today and lamb production in spring. And I will present some of the results from the grazing studies that I conducted at Lincoln University in New Zealand, and more recently at Oregon State University in Corvallis. Okay. Just to give a short introduction about myself, I briefly did my PhD at Lincoln University in New Zealand between 2004 and 2009, and I worked at two different international agricultural research institutes in the Middle East, where I conducted research on forage agronomy. And in 2016, I joined my position at Oregon State University, where I started to work as the forage livestock system scientist. Basically, I teach livestock production and pastures and sustainable crop livestock farming systems here at Oregon State University. And currently I'm busy with my research on the dual use pasture systems, where I look at the effects of different pasture types and grazing management on lamb growth and pollinator health. I'm also running a feeding experiment with spent hemp biomass, which I'm not going to talk about today, but a grazing experiment under solar panels, which is called agrivoltaic systems. I'll briefly touch base on that one as well. But I wanted to start my talk today the New Zealand lamb production systems a little bit, because it's just highly dependent on the pasture systems, pastoral systems. And then I will talk about the dryland legumes and lamb growth. And at the end of my talk, I'll again briefly touch base on the lamb production in agrivoltaic systems. So when we look at New Zealand in general, the pasture-based production systems is quite prevalent, and almost over 35 million acres of land is dedicated to pasture production there. There's a relationship between the class of livestock and the climate and the topography in general. New Zealand almost have two-thirds of its country. Two-thirds of the country is just the hilly or mountainous, and most of the sheep production happens in those the dryland type of environment. And in the plains, either it's the intensive finishing systems or the dairy farming with the help of irrigation. So it's just quite a bit of pasture-based farming systems going on. And like I said again, the sheep production part happens mostly on the hill country, or in the hard hill country, where the dryland, the pastures are mostly available. So in most of the country, basically perennial ryegrass, white clover-based pastures are predominant, but almost 7 million acres of New Zealand is affected by summer droughts, especially in the east coast of New Zealand. And in these areas, basically, suffer from the summer drought type of conditions, and the pastures basically look like the one on the right-hand side, where you guys see. So in New Zealand, both milk and lamb production are highly seasonal. Basically, the lambing coincide with the rapid forage growth in early spring, and then the lambs are finished in about 3 months before the onset of summer dry type of conditions. The lambs are slaughtered is typically 30 or 40 pounds smaller than the US lambs, mainly because of the fact that they have got the market for this one in, whether it's in the Middle East or Central Asia, China, or the North America. And if I remember correctly, almost 50% of the total global lamb export is coming from New Zealand. So they have got a very, the big share in the export market for the lamb production. So the intensive finishing system requires providing high quality forage to lambs and lactating ewes in spring. But if the lambs are not brought up to the target slaughter weight, they are most likely to put onto high quality forages in sort of like the late spring summer period, something like alfalfa or the brassicas. In most cases, they they grow turnips and sweets. Okay. So for this the short production period, it is just really pivotal. It's really important to feed them well with high quality forages, and just to to enable those lambs to gain as quick the live weight as possible. So mainly because the higher live weight gains of the lambs, the shorter they stay on the farm, and in total basically they require less energy, mainly again because of the fact that they just have to spend less maintenance energy in the long run. So you'll be basically producing the lambs with high growth rates, but the shorter period of time, and it will save a lot of the energy in terms of the total production. So basically what is the secret for the high production and high quality forage? We know that the nitrogen deficiency in our pastures is a common problem. Overall, in temperate type of the pastures, the main limiting factor, it's even more than the water limitations, it's the nitrogen deficiency. So if we wanted to include more nitrogen in the systems, we have got two different the ways to do that. One of them is applying chemical fertilizers from outside, or adding clovers in the system that can fix atmospheric nitrogen through their symbiotic relationships with the the soil bacteria. Okay, and these are also can be seen in these figures as well. Basically, for every metric ton of forage biomass production, legumes fix approximately 25 to 30 kilogram of nitrogen. And for example, for the white clover is considered almost the white clover can fix up to 250 to 300 kilograms of nitrogen, tons of nitrogen per acre basis annually. So this is quite a bit of decent amount of nitrogen in the system coming specifically from the legumes. Also, if you guys take a look at the figure in the right-hand side, so it shows that the higher the legume in the component in the pastures, so the higher the lamb live weight gains can be achieved. So from both agronomical perspective and also from the animal nutritional perspectives, we really like to have more legumes in pasture-based type of the systems. Almost invariably in most pastures, white clover is the most widely grown legume species. And as you can see in the left-hand side picture, it has got high quality forage and really leafy type of the pastures it produces and provides, and it fixes a lot of the nitrogen in the system as well. It's generally easy to basically manage white clover, mainly because it's a prostrate type of the clover. So from hard grazing, it doesn't get affected too much. But one caveat with that one is just that it has got shallow fibrous root system, so it doesn't really tolerate the drought conditions, especially if it is on the hillsides, right, or like in the photo in the pictures on the right hand sides, or in the dryland type of pictures. So white clover is excellent, but it doesn't tolerate the drought conditions. So what are the options in dryland type of the pastures where the sheep production is just mostly take place, right? So we have got basically two options to include the legumes and improve the legume production from our dryland pastures. The first one is we can have pasture species like alfalfa, Kura clover, Bursa trefoil, these type of the forage species with deep taproot. So these, the plants with their deep taproot, they can the access to soil moisture or the water in the deeper profile of the soil in summer period of time so that they can persist and they can be productive, right? That's just the one typical way. And these basically the legumes like you guys, the seeing in the graph down in this graph. Basically, they are a little bit slow in early spring. Just don't be, confused by the months. They are from the southern hemisphere. They are a little bit like, the slow in early spring. And then when it comes to summer, they just suddenly grow really like, the high, at high growth rates, like, the one in this case, like an alfalfa as compared to pastures. So in summer, they produce quite a bit of like, the decent forages, right? Mainly, again, because of the fact that they can access the soil moisture from the deeper profile of the soil. So this is one way to include the legumes in our dryland pastures. What is the other way? It's using the self-regenerating annual legumes. Basically, the most commonly used ones are subterranean clover, balansa clover, and annual medics in most like the places, dryland type like the places. They typically germinate in the decent after the decent fall rainfalls, and they just grow a little bit and they stay dormant in winter period. And in early spring, there is a sudden, the flash of growth, the high quality forage. And as an annual, they think that, oh, I'm gonna die in summer, so I just need to produce flowers and produce seeds. And again, the plants basically ultimately they die in summer. And throughout the summer period of time, they stay in the soil as a seed, so they don't really care if there's moisture or not, right? One of the other benefits of these annual legumes, self-regenerating annual legumes with high amount of hard seeds are they have got lower temperature requirements, so they grow in early spring really real rapidly, more than quicker than the perennial legumes. So this even actually like enables the farmers to even lamb a little bit early in early spring, so or late winter, just to be able to take advantage of these early growth of annual legumes. But one thing is these like the subcolors basically, I guess in here it starts flowering from March to May. And then as an annual plant, the seed production is quite important, right? So because it's going to produce a lot of forage, but at the same time, it needs to produce seeds for its persistence and also its regeneration for the next years. Therefore, the grazing management needs to be optimized for animal and seed production at the same time. Regarding the management of these self-regenerating annual legumes, such as subterranean clover or balansa clover, or the same way in annual medics, there is kind of like a conflict between the seed production, animal intake, live weight gain, and onset of the summer droughts, kind of like in the conditions. So we should be really mindful about how we just graze these the pastures. I took this picture in 2007 when I was doing my PhD at Lincoln University. You guys see that how the lambs they graze these pastures so close to the ground. It's an orchard. It was an orchard grass subterranean clover pastures, but the plant has got still some flowers. So these the points can also be shown in this picture. In spring, farmers want to get this maximum intake of high quality legume feed by ewes and lambs, so that the lambs can be finished before the onset of summer conditions. But at the same time, if the livestock eats too much of these, the reproductive part of the plant, and then the regeneration will be poor in the next year. So because of that, there is always kind of like a the trade-off between the animal live weight gains and also the basically the seed production. So bearing in this mind, we wanted to design a study where we wanted to apply different stocking rates and the closing dates in pastures. So in one case, we applied low stocking rate, which was 8 ewes per hectares with the twin lambs, and then the 14 ewes, 14 ewes per hectare with the twin lambs. And we had different closing dates in spring. Again, don't be confused with the dates. They are the spring, the months in New Zealand. So basically, we just had really, really good live weight gains of the animals over like, the 250, 300 grams. And at the end of the day, the low stocking rate lambs, were about 30, 40, kilogram, which was around like, again, 90 to 100 pounds, which were really, really impressive. So for subterranean clover, we wanted to see those like the little high quality type of forages next year in the pastures. And they say that if you have got 1,000 plants per meter square, which means that it is really highly efficient and the effective type of the system. So in our pastures at 4 different closing dates in 2006 and 3 different closing dates in 2007, we had really like the successful system with those annual legumes. So what we learned from the study was, and I just wanted to get this message across with you guys too. It is the fact that the high lamb live weight gains they were achieved by high from the pastures with high clover percentages. So the higher the clovers you can get, the higher the lamb live weight gains. That's just one thing. From the subterranean clover regeneration perspective, the lower stocking rate or earlier closing dates were just really efficient. You don't have to do this one, this type of system every year if the subterranean clover populations are high in your pastures. It doesn't have to be subterranean clover populations, actually, any type of the annual legumes in your system. If they are low, then you can basically close a little early or apply lower stocking rate, but otherwise you just can graze like normal pastures. So basically after I started at Oregon State University in 2016, I wanted to start designing pasture grazing studies for both the high input or low input type of pasture systems, whether it's like the dairy production or like the sheep production systems. And this one is one of those studies that I conducted 2 years ago. And again, like I looked at different type of like the pasture legumes, which I'll be talking about that one. In Oregon, where we are in the West Coast, in early spring or winter, we have that high amount of rainfall and the pastures look really great. I mean, a lot of like, the forage production, animals are happy, pastures growing really, rapidly. But when it comes to summer, in June and July, everything dries out very quickly because we don't get any summer rainfall, right? So because of that reason, before this summer drought happens, we really need to, to grow our lambs as quick as possible, whether, they are finished or they sent to the market or whether they are sent to feedlots. It's just really important. So I wanted to look at different types of legume options in this area. So I planted tall fescue with subterranean clover, which is a self-regenerating annual legume, or Pollensa clover, which is another type of annual legume, and tall fescue with Bursa trefoil. Bursa trefoil has got deep taproot and it's grown, as far as I know, in the Utah and Wyoming quite a lot. And tall fescue with white clover. White clover, as I mentioned earlier, it's one of the most commonly grown clover species, but it doesn't tolerate the drought conditions. Or in another the type of pastures, we basically put all the legumes together with tall fescue. So this is an aerial photo from our study area. Again, you guys can see tall fescue balanza in this one, Bursa trefoil, subclover, tall fescue. This was white clover on the side and a mix of all the legumes in this one. So basically, we partitioned all these, plots in 3 different subplots, and we grazed them at 7-day, 21-day rotation at 7-day, the type of intervals, basically. And we replicated this one 3 times in the study. So this is a picture in early spring. I think it was mid-April when we started the grazing this one. We were a little bit late in the first year, as you guys can see that a lot of the Pollensa clover and the lambs are happy. They are growing really rapidly. I tend to graze these pastures a little bit hard in spring just to keep the quality high in late spring period. And this is how Valencia clover looked like after I grazed this, I think it must be the first or the second rotation. Okay, and this is just right after 2 or 3 weeks later. So how much, how quickly the Valencia clover comes back again and it starts flowering. So later in the season, the plants go into full bloom, and then it just produces a lot of the flowers. And later in late spring and early summer, you just leave them basically for the seed production so that they can come back again, in late fall. In this study, basically in early spring period, we didn't have any differences in the live weight gains of the animals, as you guys can see, mainly because of the fact that all the forages were grown really at high rates and high quality. But later in spring, if you take a look at this one, tall fescue Valencia clover and tall fescue mixed clover type of pastures, the lambs grazing these pastures, they gained the higher lamb live weights. And there was only one reason for that one, and that was just a higher legume proportion in the second, in the period of those, the second period of that experiment. Typically, Valencia clover stayed over the 25 to 30% of the legumes, and then the same thing with the tall fescue with multi-species type of legume mix. They were in the high and sort of in the highland live weight gains in late spring were able to be achieved. So basically in this study, we confirmed that high legume contents leads to high lamb live weight gains. Valencia clover, we actually tested Valencia clover for the first time in a graze type in the condition in Oregon. And we just noticed that it can be an excellent alternative to subterranean clover. It has also a comparative advantage in waterlogged sites, which is a very common problem in Oregon. So using multi-legume mixtures combining soft clover, Valencia clover, or deep-rooted pursuit trefoil can actually be a very good strategy in especially dry areas or the hilly sites, so that the legume component of pastures can be increased. Up until this point, I really wanted to highlight the importance of the legumes in spring, especially in dryland type of the pastures, how much they can contribute to forage production and at the same time the lamb live weight gains. And I wanted at this stage talk about this grazing under solar panels, which is also called agrivoltaic production systems, which is becoming quite prevalent, especially where I am in Oregon. There are very many the energy companies, they wanted to establish their solar panels in the agricultural fields. There's kind of a push and pull type of relationship with the farmers or the publics, because they don't want to see the the solar panels in the agricultural in the fields, but the the energy companies just basically know that the energy production from the solar panels are the most efficient in temperate type of the climatic area. So what is the the trade-off between these two, the agricultural production and at the same time the energy production? So we wanted to do this study, and we again designed a sheep grazing study, and in this study, basically on one hand we had the lambs in open pastures, in another hand we just graze the solar pastures. So in the United States, it's one of the reasons why I really admire and like this country. Basically, if there's sort of business the opportunity, immediately the people get together and fill that the gap. So there is actually at the moment an American Solar Grazing Association. So basically they form a group of they just get together and form a group to graze this type of agrivoltaic type of the lands. So in these areas, this is how the pastures look like in different seasons. In winter, the grazing ewes basically they like to stand or stay mostly under the solar the panels whenever the rain comes. So it's kind of like a shade area in both winter and spring or summer times. And in spring, these areas, like in most of the annual type of, the grasses come really quickly. In summer, where the sun is just like in the excessive, or where there's not much shade, the forages like the die out very quickly. But on the other hand, directly under the solar panels, they just still stay green. But in fall, when the rain comes back again in between the solar panels, the forage starts growing. But since the water doesn't become available, let's say under the solar panels, those areas are really the dry. It's just really very the interesting type of production pattern under the solar panels. But again, like I said, it's just becoming really the prevalent in the pastoral type of land in Oregon. So we wanted to see the effect of these pastures under the solar panels and the grazing systems. And we designed a study and grazed in early spring, either open the pastures or the pastures under the solar panels. Basically, the direct shade under the solar panels reduced the pasture growth, as you guys can see in this graph. Partially shaded or open field, they were almost very similar in most cases. In one occasion, in late spring or the summer period of time, the pasture production under the solar panels were a little bit higher than the others, but in most cases, overall, the pasture production under the solar panels or the solar pastures was 35 to 37% less. So the live weight gain compared to this differences in forage production didn't change much in either year. And similar to the live weight production from these pastures, basically, the lamb production per acre or per hectare basis were the same. And the main reasons for that one, basically the pasture quality was a little bit higher under the solar pasture side. And also we believe that those animals under the shade, basically they needed less sort of the maintenance energy to regulate their body temperature. So their the growth rates were more efficient as compared to type of of open pastures. We also looked at the daily water consumption of these animals, and the ones under the solar panels in the first period in 2019, spring 2019, were similar, but in the second period they were a little bit the lower. We just had sort of the similar pattern in 2020, but the impact of solar panels on the water consumption was less prevalent compared to the first year. When we combine the energy production and the land production in the same place, we noticed that you can actually increase the productivity of the land quite a lot. So our land's equivalent ratio from these in the solar pastures were quite high, despite the fact that the land production was just tiny little, forage production. Sorry, the forage production was tiny a little bit less than the open pastures. So this is, I think, very, very interesting type of the finding. If the system can be optimized for both agricultural production or lamb growth in this case, or and also the solar energy production, then it can be really potentially a very, very interesting type of the production systems as well. That study we conducted was unimproved type of pastures, and I think the pastures were about 20, 30 years old. And this year we decided to establish really high quality pastures in between the solar arrays. And you guys can see one of those pastures, which I called it herbal lay. So you guys can see a lot of chicory, plantain, and legumes as well. And we just finished the grazing of the first year yesterday, and the lamb growth rates were phenomenal, which was in the between 200 grams to 350 grams, depending on the pasture types. So this is, I believe, that very, very interesting type of production systems. I know that the political situation, just the energy production in this country, and the using agricultural land from these areas. They're all really controversial areas, but from the science perspective, I really wanted to, to provide a picture what it is really. I mean, if we can use these areas for the agricultural production, would it be really, useful for the animals? And I have got a lot of ideas for the future. Something like I may be able to use these areas kind of like a forage bank in summer, where the summer like the forage, like in the production decreases quite a lot. Okay, so this is a picture from a recent study that I conduct. Basically, this is just the development of dual use of pastures for sheep production and the pollinators. In Pacific Northwest, there's a big drop of the pollinator populations, and we wanted to promote those, really useful type of creatures for our agricultures and biodiversity perspective. And I just designed this study basically thinking that pastures can provide both options. I mean, in one case, they can provide forage, high quality forage for the lambs, and also, the nectar source for the pollinators. Again, this one also, we finished this grazing trial yesterday for the spring, and I stockpiled some of the forages for flower production and for the pollinators, and as well as the grazing opportunity for late in the summer. So one of my colleagues are measuring how many the bees visit these pastures. Basically, in the same time, the lambs are grazing these high quality forages, and the lamb growth rates on these legume pastures were impressive. I think it was 0.65 pounds per per day per animal in late spring period, which is just quite phenomenal. And there are a lot of bumblebees or honeybees who are visiting these areas. I actually originally didn't want to mention this study much, but this was something that I did in Central Anatolian Plateau in Turkey. Mainly because the previous speaker talked a little bit about the creep feeding systems, but this is a creep sort of the feeding system in pasture type of the production. I had this on the left-hand side, the permanent pastures where orchard grass, white clover, pursuit trefoil were grown under irrigated type of situations, but regardless of the irrigation, because of summer dormancy, these, the grasses basically slowed down. And I wanted to, to provide something to the legumes, growing legumes on the side. I either planted, pursuit trefoil, like in this picture, or alfalfa, or in another case, I just, provided creep concentrates to these lambs. Only the lambs could just, come in here. So basically, they were grazing with their mothers in early spring, and in late spring, the lambs were able to access to these type of, the areas. So what we found out in this study, if you don't provide any of these, the supplemental type of feeding, whether they are in the form of legumes or concentrates, the lamb growth rates, decrease very rapidly. But if you provide, the some of the legumes or, the concentrates, you can still, retain lamb live weight gains as high as possible. So this was in the first year, and this was in the second year. And we also did sort of a bioeconomical type of analysis, because the concentrate prices are always high as compared to legumes, and it just appeared to us that if they provided legumes, either alfalfa or pursuit trefoil, the productivity or the biochemic efficiency was higher in those the pastures as compared to the lambs were offered concentrates in the creep feeding period. I guess this is what I wanted to talk about today. I really wanted to highlight the importance of legumes in dryland pastoral systems, and I wanted to finish up my talk today in this picture what I am with a farmer where we overdrilled pursuit trefoil in his the pastures, and the pasture productivity increased quite a lot, and quality increased a lot, and the farmer, as you guys can see from his face, he was really super happy. So this is all I wanted to talk about today, and if you guys have got any questions, I'm happy to take those ones. So I see one question: can legumes grow in a primarily dry environment? There are always, like, the legume species can grow in different type of, the agroecologies for sure. Today, I mentioned primarily about subterranean clover and Valencia clover as the self-regenerating annual legumes. They are mostly, to be honest, they mostly suited to Mediterranean type of, the climate. They cannot tolerate sort of like, the harsh winter conditions. If you have got harsh winter conditions, like if you are basically based in Idaho, Wyoming, Utah, those like in the subclover and Valencia clover, they won't have any chance to survive through winter, but you might be able to use annual medics in your pastures, and they will still be able to, like, to produce a lot of, like, the forage in early spring, and at the same time produce a lot of, like, in the forage as a self-regenerating annual legumes. Another one, which I know that Jennifer McAdam from Utah State University, she has done a lot of work on Bursa trefoil, and she has fantastic, the results, in terms of the beef, growth, and can be still the, like, the sheep growth as well. In particularly cultivated type of pastures, Bursa trefoil can be really, really productive in dryland type of environment. I assume that Bursa trefoil can still grow as low as 15 to 20-inch rainfall, but if anything less than that one, then in that case, irrigation is needed, or alternatively, annual medics, can be grown in those areas. But again, if you wanted to grow something like white clover, then it's just very difficult to produce something like that. Okay, does this answer the question? I think Jean Edmonds, so I cannot see the last name very well, but Jean asked this question, so I don't know if this answers the question.
Yeah, I think you answered that really well, Dr. Tesh. I think I had very similar questions, and I think you answering and what rainfall ranges some of these clovers can grow, I think help answers that a little bit better. I originally am from Arizona, and I think some people on here are from Texas, and so being able to answer maybe what are some options for some producers that are out on rangeland to either help increase productivity on range, or should they maybe put more focus on their pastures that are closer to home that maybe they bring on for breeding or during winter?
I think both cultivated pastures and then the rangelands, the productivity of those pastures, basically, they can be increased by including legumes. I know that in New Zealand, they have got a lot of emphasis on legumes, mainly because of the fact that they know that the most limiting factor in those pastures are the nitrogen, even more than in the water. Basically, if you can increase the nitrogen, content of the soils, basically you can grow more grasses, right? And then the legumes are high quality, and then they can just, promote high limb live weight gains. When it comes to rangelands, I must confess that I haven't done a lot of studies, but more recently, I have got a project that I wanted to test against some of these medic species, especially in Eastern Oregon. And also, I wanted to test falcata alfalfa, which is a very, very drought tolerant type of legume, and it's just really, the grazing tolerant. There are really options available in terms of the legume, even if it is just really, the low rainfall environment, whether it's the natural type of rangelands or, the cultivated type of, the forages. So the important factor is increase the forage quality and increase the legume component in the pastures for the nitrogen fixing ability.
That's
I
great.
haven't mentioned about alfalfa much, but even in my studies, when I did my PhD, I grazed alfalfa, which is a very common practice in both Australia and New Zealand, and even some South American countries, as far as I know. They graze straight alfalfa very, very successfully. I know that the bloat is a really a common issue, and I just had a lot of, like, the negative experience on that one. But in New Zealand and Australia, they just developed really very successful type of, the grazing systems with alfalfa. And in dryland type of areas with sometimes a little bit of irrigation, nothing can produce as much as alfalfa, and it can really promote high limb growth rates as well. In my previous study that I mentioned in here, I grazed alfalfa, but at the same time I applied poloxolane, which is a blood preventing type of the substance. So I didn't have any issue. But that was a little bit experimental, and I don't think that it's going to be very practical in sort of like the large areas. But there are still quite a bit of different blood preventing type of minerals or leaking stones that can be used in combination with alfalfa or burster trefoil, even if it's grown.
Yeah, that's great. Good to mention some of those bloat preventers if you're going to manage this way.
I also graze chicory and plantain quite a lot. And chicory typically, I don't know if you guys, are familiar much. It's just a very, very drought tolerant, high quality type of forage, and it grows really well in late spring, summer period. And I know that some of the sheep growers in Oregon, basically they include chicory in their pastures quite a lot, and they graze it throughout the summer period of time. So today again, my focus was mostly spring period, but there are a lot of the summer type of forages can be grazed by the livestock too, and chicory is one of those as well.
Well, thank you, Doctor. I think that was very insightful, and I really liked listening to some of the research that you've done.